Hi, my name is DWatson. I'm a faculty member in the Department of Chemistry and Biochemistry here at the University of Delaware. And I want to thank you for taking time to have interest in my research group and to check out what we're doing. Our group is an organic chemistry group. We do organic chemistry and a lot of organometallic chemistry. We develop new reaction methods for applications in complex molecule synthesis. This means that we spend a lot of our time thinking both about what reactions are important for organic chemists to be able to carry out important efforts like drug synthesis. And we also think a lot about mechanism and organometallic chemistry in order to leverage transition metal catalysts to be able to carry out and invent new reactions for applications in those areas. What my group has decided to do today is to have the research group itself tell you about more details of the science. So what follows, the group will introduce themselves. Some of the members of my research lab will introduce themselves and tell you about some of the projects that they work on and some of their interactions in the group. There's also a lab tour, virtual lab tour at the end, so you can see the spaces that we work in and the students in the lab environment. Also, we've recorded a virtual poster, and I encourage you to take a look at that if you're interested in the types of research we do. Again, from the students' perspective, they've taken the time to record a video to basically explain the projects that they are working on and the project areas that they're working on. And so I hope you find that to be really informative. If you have any questions about the research lab, I strongly encourage you to reach out to me. I'm happy to have a talk about our science at length. My email address is dawatson@udel.edu. And I'd be happy to sit and chat more with you about the work that we're doing and what we hope to be accomplishing in the near future with future groups of students. Thank you again for your interest in my lab and for interest in our department. I hope you find these videos informative. As I said, happy to meet with anybody who has more specific interest in the group. And hopefully we'll see you on campus this fall. Take care.
Hi, my name is Dan Rojas, and I'm a second year in the DWatson group. I'm from Westchester, New York, and I did my undergrad at SUNY Cortland.
Hi, my name is Mariah Murray. I am a first-year graduate student in Dawn's lab, and I'm from West Virginia.
Hello, my name is Katerina Korch. I'm a fifth-year graduate student in the DWatson lab, and I grew up in Pennsylvania.
Hi everyone, my name is Ola, and I'm a third year in DWatson lab, and I'm from Nigeria, and I did my undergrad in University of Lagos, and I moved here after my undergrad.
Hi everybody, my name is Alyssa. I'm a third year in Don's lab, and I'm from Pennsylvania, outside Philadelphia.
My name is Jacob Hayes. I'm a second year graduate student in the DWatson lab. I'm from Greenville, South Carolina.
Hi, my name is Rafael. I'm a fourth year graduate student, and main projects I've worked on are in the nitroalkane chemistry, along with directed CH4 relation and asymmetric reductive homocoupling.
The reason I chose to join the DWatson lab was because I thought it was the most interesting and exciting research program within the department.
So my relationship with Don, I'd say, is a really excellent professional relationship. The way he manages is to make you, he will guide you along in your project, but mostly your project is supposed to be driven by you, which is great for you to learn how to manage your own PhD and your own career. And group meetings are geared to make sure everyone is learning. He's really big on learning and keeping up with your continuing education. So, you know, working on your mechanisms and your basic organic chemistry knowledge.
So I really enjoy going to conferences, and it's something that Don has really been supportive of. So I've been to 6 conferences and poster sessions, and they're not all right here in Delaware. That covers 4 different states, including ones that I flew to, which is really cool. And what's nice about conferences is you get to meet other graduate students from other schools, as well as people in industry, and you get a chance to get feedback on your work, not just from people from your university, but from people from all over.
So my typical day in the lab starts with, in the morning, I normally read or write stuff for an hour or two while I drink my coffee. And I'll go into the lab, take some NMRs, work up any reactions that need to be worked up. I'll probably set a few up at that time too. And after that, I'll go and calm and purify a few reactions. And then at the end of my lab day, I go and make a list of what I need to do the next day to stay organized. And I also end the day off with doing some more reading and writing.
Yeah, so Don's expectations are that everybody works hard to make progress on their projects, as well as to help the other people within the group also do work on their projects. So as an older student, I do a lot of mentoring of the younger students, in addition to working on my own research projects.
So the first question I'm going to be answering is, how is the mentorship system in the lab working out for you as a first year? I think the mentorship system has been great. What has happened is I was paired up with a more senior graduate student, and she's been working with me every day, helping me gain independence back in the lab since I haven't been in for about a year. She's been super helpful, and so is everyone else. You can go to anyone in the lab, and they're more than happy to help you find a chemical or talk through chemistry ideas with you, or even just to chat about your day. So the mentorship has been great, and I've really had a great experience with all the senior members in the lab.
So are there any lab traditions in lab that made me feel more connected to my lab mates? I would say there are a few, especially during my second year when I was preparing for the candidacy exam. A lot of the seniors who you guys wouldn't meet because they graduated were very helpful. They would make sure you're reading the right materials. They would make sure your writing is good. They help go through the writing. And all of those processes made me really feel connected to members of the lab.
Currently, I'm working on the AZAHEC project. Previously, the group developed a method to synthesize 5-membered unprotected lactams. I'm currently expanding this methodology to include the synthesis of 6-membered lactams as well as N-substituted lactams. Although the project was hard to kick off at first, I've become very endeared to it through my progress. Although this progress I didn't do completely alone. I had a lot of help from both postdocs and the older students in the group, whether it be through reaction conditions or new ideas to try in my screens. I relied on them a lot through the development of my reaction. Being able to develop this reaction has been rewarding, and just knowing that I'm going to be able to increase the number of tools in the synthetic chemist repertoire just makes me feel like I'm doing something really productive with my time.
What are you currently working on in the lab, and how excited are you about it? So my current projects that I'm working on currently are on the C alkylation of nitroalkanes, directed ortho-C phosphorylation, and asymmetric reductive homocoupling of aryl halides. So I am focusing more on the mechanistic studies of the C alkylation, or the nickel-cal C alkylation reaction that hasn't been published yet, and I'm also working on the mechanistic studies on the asymmetric reductive homocoupling of aryl halides. And I'm excited about because it's a new, I guess I haven't, it's kind of exciting to work on a mechanism, on the mechanistic aspect of a reaction, and also being able to collaborate with other professors from different universities. So for both of these projects, we're collaborating with Professor Oswaldo Gutierrez from University of Maryland. His side is more computational studies about indus mechanistic studies. And so, yeah.
There are several places. So in terms of the school itself, I like to go to sporting events. Main Street, getting food on Main Street's great. Especially, I love brunch. So I love going to this little mom and pop shop on Main Street called Sinclair's Cafe. And my friend and I always go there once a week to get a really, really good brunch. And then I also like going to the movies. With COVID right now, it's not really an option, but they have a really nice movie theater on Main Street. And then around Newark is a lot of outdoorsy stuff to do. So we have a big state park, so White Clay Creek State Park. It's huge, lots of trails, lots of outdoorsy things you can do. And then up towards the north is, the south actually, is Lum's Pond. And it's another park, but there's also a giant pond, so you can kayak, canoe, fish, that kind of stuff. And that's what I like to do with the outdoors.
Hi, I'm Mariah. I'm a first year in the DWatson lab, and today we're going to be touring our lab. So we're located in LDL labs 224, 225, and 226. We also have offices in 202, 203, and 204. So let's take a look. This is Super Geek's lab area. He is a postdoc in our group. And now we're going to go talk to Jacob about the biochemistry in the green box. We also have a glove box located right here. Jacob.
Glove box here. This is one I use. It's currently equipped with valves for ethanol stuff. We also have a few waste valves here, as well as routine complexes too for any waste calculations that will be.
Thank you.
Here we have the biochemistry system that Kat's using.
It's super great. It is an automated way to purify your materials. We actually have two of them. The other one is getting repaired. We have an awesome instrument shop here where they're able to repair a lot of stuff for us in-house.
All right, let's pop into 226A and talk to Ellie. This is also Ola's work area, and he's the one behind the camera right now.
Hi everybody, so in this section of the lab, in this cabinet we have our Costco chemicals, aka our oversized chemicals that you could find. And then this cabinet are all the chemicals that we inherited from the lab that was here before us, the Tabor lab. And then the last one, and my favorite in this room, is the cabinet that has pretty much all of your favorite organic chemistry functional groups. So you have your ketones, your amides, carboxylic acids, aldehydes. And just a fun fact, in our lab in general, we have over 4,500 chemicals in our inventory. So you have a lot that you can choose from to do some cool chemistry with.
All right, now we're going to go talk to Raphael in 225. Hey, Raph. So Raph's going to tell us about the photoreactors and the IR.
Hey, so my name is Rafael. I'm a fourth-year grad student, and this is our React IR here. It's basically an instrument that is used to measure the reaction or monitor the reaction in real time. It helps us really understand the mechanism, kinetics of the reaction, and how different reagents in the reaction influence the reaction. So the bottom here is our photochemical reactors. We have two. We have the Merck photoreactor, and we also have Tesla here. And it's basically used for photochemical reactions.
All right, and this is just more of our lab space. This is Humair, one of our postdocs. This is the glove box that we have here in the lab. This is the current hood of a first-year graduate student doing a rotation with us. We just have bulk salts, old lab notebooks, things like that. And we also have an IR over here. So now we're going to go talk to Dan about the glove box. This little cubby is my workstation as well. This is Dan's area. As you can see, we have lots of windows in the lab, so you can get nice views while you're here throughout the day. And here's Dan. Hi, Dan.
Hi, everybody. Alright, so over here we have our glove box where we run most of our transition metal-catalyzed reactions. This is where we do all of our moisture-free chemistry because there's a nitrogen atmosphere. So we have bins of palladium, of any precious catalyst, as well as air-sensitive phosphine ligands and nitrogenous ligands. And over here to my left, we have all of our ethereal dry solvents. We only have 4 in-house. We're able to go around to the department and grab whatever dry solvent they may have in their dry solvent stills.
Thanks, Dan. All right, so now we're going through the rest of the lab. We actually share half of our lab with Mary Watson's lab here in the department. Here we have the HTE boxes. So that's high throughput experimentation that you can do. And these will be moving to their very own facility pretty soon. We also have an instrumentation room in here. And there's Jacob again. So we have GCs in here, HPLC, and this is where Austin works, and he works with the HD boxes.
So we have 3 GCs in here. This one is our standard GC that we use for all our routine analysis. This middle GC has 2 power columns on that we use for asymmetric analysis, and then this is our HD GC. It has space for 96 volt plates, so we can run that after doing our HD experiments. And also we have 2 HPLCs that are also equipped with power columns, so we can do more asymmetric analysis.
All right, and that takes you through our labs. So as you can see, we have a lot of great people, a lot of really great things going on here, and we really hope to hear from you soon. Sorry. Thanks.